Fuel feeding system. The fuel feeding system consists of a husk bunker, vibro feeder, mixing nozzle, fuel feeding pipeline, and front feeding fuel nozzles with turbulators. Husk from the bunker is fed by a vibro feeder located at the bottom of the bunker to the fuel feeding line. The feeding rate of the husk can be varied by adjusting the voltage supplied to the vibro feeder. The vibro feeder feeds the fuel into a hopper fitted on the mixing nozzle which is on the fuel feeding line. The mixing nozzle consists of a convergent-divergent nozzle assembly which mixes air with the fuel and conveys it into the furnace. The air required for the conveying system is taken from the FD fan combustion air duct. The fuel is sprayed inside the furnace by turbulators in the fuel feed line. Combustion system. The system consists of a husk bunker, vibro feeder, mixing nozzle, fuel feeding pipeline, front feeding fuel nozzles with turbulators and furnace. The fuel sprayed into the furnace burns inside the furnace in suspension with the combustion air supplied through the air nozzles. The air nozzles are designed with sufficient pressure drop to burn the fuel in suspension. The air required for combustion and fuel suspension is supplied by means of a FD fan connected to a combustion chamber through an air duct provided with a damper for manual control of airflow. The honeycomb lining in the furnace supports the combustion by acting as a porous media and also by re-radiating from the refractory. The temperature in the furnace is about 750 degrees Celsius to 850 degrees Celsius. Flue gas circuit. The fuel thus burnt in the combustion chamber passes through the honeycomb lining and reverses in the IRC to enter the second pass tube banks at 750 degrees Celsius. The heat in the flue gas is absorbed by the second pass tube bank and the gas temperature drops to 450 degrees Celsius. The flue gases again reverse in the ERC and enter the third pass at 450 degrees Celsius. The heat in the flue gas is absorbed by the third pass tube bank and the gas temperature drops to 260 degrees Celsius and exits the boiler. The tube banks are sized for an optimum velocity of 18 meters per second. Before exiting out of the chimney, the flue gases pass through an ash room where the ashes in the gas are collected by gravity. The ash collected in the ash room has to be periodically removed and disposed. Water steam circuit. The feed water required for the boiler is pumped by means of a centrifugal pump. The pump is connected to the boiler with a NRV and globe valve. A standby pump is provided for emergency purposes. The water in the boiler absorbs heat from the furnace and tube banks. The heated water boils, converts to steam and increases the pressure of the boiler. The boiler has sufficient steam space and water-steam interface area to give high-quality dry steam. The main steam valve is opened at the required pressure and steam starts flowing to the process. Two safety valves are provided for blowing off steam when the boiler pressure crosses the designed limit. AWLC. The boiler water level is maintained by a float and level switch arrangement. The feed pump is switched on and off by the float, which moves up and down based on the water level inside the boiler. The steam of the float has 4 magnetic switches, namely off, on, low and very low. These switches the pump on and off with respect to the water level. When the water comes to very low position, it will trip the whole boiler.